So just to understand the odds here, how many people here have experience with Ruby? Okay. How many people here have experience with unit testing in Ruby? Okay. How many people here have experience with test first unit testing in Ruby? So it keeps it going by half. It's good. It's a good algorithm. Okay. How many people here have used RSpec? What else did you guys use? Those.
Test unit, spec unit.
Test unit and
Mini spec and
mini test.
mini test and mini spec. Yeah.
Okay. So I just want to set the expectations straight here. This workshop is for people that might not have any experience with either Ruby or unit testing in Ruby. Okay? So if you come here with existing experience, be prepared to maybe already know some of these things. Okay, so no hard feelings if that happens. For the people who haven't done Ruby before, where do you guys come from? Which languages? Morten?
.NET, C#.
Yeah.
No, I mean Pascal, actually.
Pascal, okay. I come originally from Visual Basic 5 and 6, and then moved over to C# and did some Java and C++, Python and Ruby. So I get the full range of differences. It's very interesting. Anyone here from the Java world? Who knows C# here? Okay, so it's about a mix. Are there any expectations for the next 3 hours? That you something that you really want to learn how to do? Are there any conversations that will be going on? Will anyone be speaking back when I ask questions here? Raise your hands if you will. That's good, that's good. I'm happy to hear that. This is the first time I'm doing this workshop, which is exactly the reason why it's free. But I hope that in the process, we will all learn some interesting things together. I'm relatively new to Ruby. I've only been doing it for a couple of years. However, in the .NET world, I have extensive experience in unit testing and test-driven development, also in the Java world. And some of the practices that I bring with me from those worlds apply here, and some of them don't. And we might talk about that a bit later. Now, how many of you know what TDD or code kata is? Anyone? Okay, about half of you. So what a code kata is, a kata in martial arts is a set of repetitions, or precision repetition really, where you repeat the same movements and try to perfect them as you do them. And while you do them, you learn two things. First of all, how to achieve basic movements if you've never done them before. And if you've done them before, by repeating them, you make them more precise, you make them better. You understand better why you're doing them. So there are two levels of learning here. One is that code katas are a way to learn how to do things. So they're just exercises if you've never done them before. And if you've already solved the exercise, as you do them multiple times, you discover different ways on how to do them. You discover different ways that you can either optimize or make things more readable or more understandable. Or you can maybe understand that you were doing it wrong the whole time. And this is what I'm going to introduce here. There are many code katas. One of the most known ones is string calculator. I'm going to move this for a second. Now it's a bit more romantic, isn't it? Nobody go to sleep yet. String calculator, if you go to Osherove.com/kata, or you just Google for string calculator, you're going to get to my site. So other than the huge ego picture of me, that's just, I have a huge ego, sorry. This is the book I wrote here. There is this set of steps here, string calculator. So you should have that on your screen. And there are two ways to treat this, this kata. I've been teaching test-driven development and unit testing for more than 6 or 7 years. And I've been using this as the basis of learning different things. Now, one of the cool things is that if you've ever done the kata in one language, let's say in .NET, in C#, trying to do the kata in a different language is just a way to learn the language, because the set of steps are the same. You need to achieve the same results. So a good way to learn a new language is to try to do a kata that you've already tried in the language that you know, and then try to do it in a language that you don't know. That will force you to learn how to do specific things in this language. And as we'll find out, there are many ways to accomplish the same thing in Ruby. Some of them more readable, some of them less readable. But the basic idea of the string calculator is just a simple class that we will have. And this class is going to be used, eventually, in a billing system. In that billing system, or a banking system. That banking system receives reports in files every night for each customer balance about incoming balances. So for each balance, you might have multiple numbers in a file, and they will usually be repeated by, delimited by commas. And the job of the string calculator is basically to calculate the sum of the numbers in a specific string or file. That's the end result. But as we get further along inside the kata, it becomes more and more complicated. Now, there is also another thing to understand about the way it's written. The kata is written to take a big problem like this, and this is a big problem if you read everything. You don't have to. But it takes a big problem and it breaks it down into very, very small chunks. And each chunk you can prove that it works, and you can actually build this thing in a very incremental manner. So this is not just an exercise, because I could just write this in one paragraph. This is a whole page of steps, of steps that will take you in very, very small increments towards the end result. And part of the idea about test-driven development is that you break things, big problems, into very, very small chunks. And for each small chunk, you implement that, and then you move on. And if you have a bug or a problem, you don't have to look or even debug, because you only changed a couple of lines of code. You know where the problem is. So that's one of the ways where TDD saves you a lot of time, is that if you actually truly take a problem and you break it down into very, very small steps, you can achieve an almost debugless life. Now, in Ruby, one of the things, when I came from .NET to Ruby, one of the things I discovered is that in the Ruby world, debuggers kind of suck. I don't know if you've noticed this. Debuggers in Ruby are just, compared to regular debuggers, they're kind of garbage. But then I realized, after a year there, is that there is a reason why debuggers in Ruby suck. It's because people, most of the time, don't really need them. They try to use them as least as possible. So for me, coming from a language like C# and looking at the Ruby world, it's like diving into the depths of the ocean and discovering a whole new species of fish there that don't even need to use their eyes because it's always dark. And in that regard, a lot of Ruby developers don't really need to use debuggers because they keep using tests all the time. And because they do things in a very incremental manner. So the muscle for debugging is very, very weak in that culture. Turn back to cultures like C# and Java. Debuggers are amazing beasts. There are whole books written. There are people who specialize in debugging applications. It's a whole myth by itself. And I think there is a reason for that, is that the testing culture there is much weaker, so different muscles have to take over. And both these things take time. One of them saves you time along the way, and the other one just wastes time all the time. So if you debugged for 2 hours now, it doesn't mean you won't have to debug 2 hours tomorrow. But if you write tests 2 hours now, it could possibly mean that you won't have to debug 2 hours tomorrow. This time is actually time that you bank, that you save as you go. So debugging time decreases as a test time increases. But test time is saved for the long run. But these are all just theories. So I thought, what is the best way to teach Ruby and also to teach the ideas of unit testing? And I thought that maybe if we do it in a test-driven way, maybe if we had to write code in Ruby, but we started with a failing test, and then we had to make the test pass by writing real Ruby code, then it will help us learn the language and also learn some of the testing idioms that we have. Now I won't cover a lot of different things because this is just purely the basics. So I won't cover a lot of tools like automatically running tests. I will basically cover the basics of some of the language, definitely not all the language. I will cover the basics of writing the unit tests. And a lot of the time we'll go to you guys just going through incrementally and doing the kata and trying to solve it in a very incremental way. Now I already have solutions for the code that you're going to write. So if you're ever stuck, I can always show you a way on how to achieve something. But the requirements are so simple that the minute you know how to do basic if statements and basic loops over arrays in Ruby and splits, etc., you should be okay without even knowing regular expressions. You should be okay in solving this. Okay? But I've seen a lot of people who implement this and use a lot of regular expressions. But regular expressions, if we're using regular expressions now, I would say that we're doing the wrong thing. Because part of this exercise is going to be about learning to delay complexity, to solve things in the simplest way possible. And then later we can introduce complexity, but we'll also already have tests to make sure we didn't break anything. But a lot of times after TDD, after test first, you realize that the code is much simpler than you thought it will be. But that only happens if you train the muscle for delayed complexity. You train the muscle that says, is there a simpler way to achieve the same thing? Is there a more readable way to achieve the same thing? And a lot of times there is, but we're trained to do things in a very, very complicated way. Are there any questions before we start? Okay, so I know I told you to start RubyMine, but I'm actually going to use a different tool because in the last couple of days someone suggested that I try Sublime Text. So I'm going to try Sublime Text because it seems simpler. Because at the end, when you try to understand what Ruby is, it's just some text that you write in a file, and then you write in a command line Ruby and the name of the file, and eventually that's what happens. And if you reuse RubyMine, it looks very complicated. It looks like there's a lot going on. But there really isn't. So I thought that maybe Sublime Text, because it works in all the operating systems, is a simpler way to achieve the same thing. So this is the idea behind Sublime Text, just a simple text editor. This is basically one of the solutions that I have to write the tests and to write the actual code. But we're going to write this in a test-driven manner and to see how things actually work. So if you have any questions, just feel free to just raise your hand or just ask a question if my head is buried in the code. Are there any questions before we start? Okay, so as I go through, feel free to just try it on your own machine. But we'll also have a period of time, maybe in 30 minutes or an hour or in 5 hours, I don't know, where you guys will have the chance to just go crazy and just pair together on the code. And I would recommend that when you do the exercises without me, and I'm not teaching anything, you actually you pair program with the person next to you. Because you will achieve things faster, and you also more fun that way. Okay, so the first thing I want to do when I want to write a test is to use something called a gem. And a gem is, if you come from Java or .NET, it's just a library that you can use. If I'm going to change this to syntax for Ruby, and I say put s hello there. This is just a simple text file. I haven't even saved it yet. I'm gonna save it to my Dropbox and say, this is TDD1, RB, okay? So this is the simplest piece of code that I can write in Ruby that usually says hello world or hello there. Now if I want to run this, I go to Tools, Build System. We usually have it on automatic, but if you want you can just choose Ruby. And what happens if I press Command B to build, at the bottom you can see that what happened is that basically went to the command line process, said Ruby and ran the file, and that's the output from the command line. Okay? Now I can do the same thing if I go to my console and go to Dropbox and say Ruby. By the way, my version of Ruby here is 1.9.3. But these exercises will work with any version of Ruby starting with 1.8.7. So it doesn't really matter what you have installed, it should be okay to run this. But if I just say Ruby tdd1.rb, I get the same output. Okay? So this is basically as complicated as it gets from now on. And put s is basically the console write line of Ruby. What I find is if we do need to do some debugging, I just use put s a lot. And some people use more complicated things. But for the benefit of just learning the basics now, it should be more than enough for you. If I wanted to, one last thing about if I'm going to use put s, I can also use variables and strings. So to declare a variable, I will just name it. Let's say Roy equals 3, or Roy equals, this is some string, it doesn't really matter. And if I wanted to, I can just include this variable in my put s string, and I will just use the hash key. So if you put anything in hash key and with these curly braces, by the way, the most complicated thing in Ruby on a Norwegian keyboard is to do the complicated curly braces. I hate that stuff. But it's supposed to simplify your life by just saying, just use Roy here. If I command B here, you get the output of what you expected it to be. Okay? So that's the most basic Ruby we need, but now we need to start writing a first test. Because in test-driven development, there are 3 basic steps. You don't write a line of production code without a failing test. That means that if you want to write a line of production code, but you don't have a failing test, you can consider the code to be read-only. Okay? You can refactor, but you can't write new functionality or change existing functionality. So you can rename, but you can't add features. So we're going to do our first failing test. Why does it have to be a failing test? Any ideas?
Yeah.
Sorry?
Should I jump in even if I've done this before?
Well, I don't know. If no one's jumping in, you get 3 jump-ins in this workshop. How's that?
1 per hour, awesome. If it passes the first time, I won't know that I'm testing the right thing.
If it passes the first time, I won't know that I'm testing the right thing. So if I write a test and it passes, it means that there's something wrong.
Well, either you already have the code, so you either wrote too much code before you wrote the test, or you're writing a test against code that you're already testing somewhere else, so you have a test you don't need.
Okay.
Or there's a problem.
Definitely, I agree with that. Let me put it in even clearer terms. The point of writing a failing test first has 2 points. First of all, at the next step, we're going to make the test pass without touching the test, only by creating production code. So by making the test fail and then seeing it pass, we're actually testing the test. Okay? Because what happens if you write the test after the code? How do you know you don't have a bug? Are you going to write a test for your test? How do you know that the test for your test doesn't have a bug? You're going to write a test for your test for your test? Is that right? It's a very recursive thing. So the best way I know to actually know that you can trust your tests is by seeing them fail when they should and seeing them pass when they should. Okay? So testing the test is basically the only way that I know how to do it is this way. However, the second reason of failing first is because systematically what I want to do in TDD is I want to define my idea of success. I want to define that I can create code that does this. I want to define that if I call this method, I get back some number. This is my definition of success. And then, when I make the test pass, I've reached the success factor. So my test is now just a flag that tells me if I got where I needed or not. So those are the two factors. You want to test your test. You also want to define for yourself a very clear target and know when you have come across it. So let's see, test. What I'm going to do is I'm going to say just require test. If I remember correctly, that's the simplest way. You can even see here, oh, sorry, test /unit. And let me get this thing right. I hate the requires. You get used to it at some point. So, test unit is the name of a gem or a class library. Okay. Now, when I pressed Command B here, what happened is that I got the initial output, but also something weird has happened. I get this 0 test, 0 assertion, 0 failure, 0 errors. And this output is now from test unit. By default, there are no tests described here. Test unit is built into most of the Ruby dependencies out there. So you can just require it and you should have no problem. And that's also, test unit is the simplest and earliest form of writing tests in Ruby. Now, a lot of people use RSpec and various different frameworks. All the things that we're going to learn in test unit will apply when you do RSpec related stuff. But they are easier to read, easier on the eye. So if it's the first time, this is actually easier for people who are new to learn. And there are values for unit tests that are about readability and maintainability that just are across frameworks. They have nothing to do with the current framework you're using. So if I want to write my first test, I have to define a method. Every test in Ruby is a method in the test unit. So to define a method, just say def. Def is define a method. We can name it anything that begins with test. That's how test unit knows anything. And. So if I just have this method here, and I press Control-Shift-B, nothing still happens because I haven't really given it a name. So I'm going to just say test something. Command-Shift-B, and what the hell happened? Let's see. I'm pretty sure that should have worked. Let's see. I can see here, this is the actual code. Oh yeah, it has to be in a class. I forgot. I don't normally use that, but this is basically what we're going to do. You create a class. The class, this is the name of it, string calculator tests. Then there is this symbol that says it inherits from test, colon, unit, colon, test case. Because these are just namespaces and then the name of a class. And then at the end, you say end. And you might go and format that. Now if I press again, I can see 1 test, 0 assertions. Okay? Now, in your output, if you're using Sublime, by default it won't have colors. But there are packages you can install very easily into your packages folder that give it color. And if you want later, I can show you how to do it, but it has nothing to do with learning the basics. It's just not something that's nice to have, and for me, it's just good for the demos.
Right.
Yeah.
Big basic. How do you actually install Ruby?
Oh, okay. So to install Ruby, you actually go to, what are you using, a Mac or PC or?
PC.
You go to rubyinstaller.org.
That's the best way to do it. Okay.
It's a very, very simple way.
Yeah.
So I just install it on Windows, this way, and then you basically have Ruby installed, and it just works. Okay? By the way, when you need to actually come in back from the toilet, you have to like ring or something, because the door has to be locked, so just so you know. Okay, so what I'm going to do is I'm going to write the first test. Now, the first test has to have a good name. Tests have to have good names because usually when we have thousands of tests running and 100 of them fail or 3 of them fail, we're not going to get different outputs based on comments or anything. What we're going to see is the name of the test. The name of the test is going to be our only hope to actually understand what's going on. Otherwise, we have to go to the code and start burying and start debugging. But if the name of this test is good enough, we might not even have to do any debugging at all. So when I write test, I usually include 3 parts in the name of the test. So the word test is just a requirement by test unit. I ignore it. And in other languages or in other frameworks, I remove the word test at all from the name. Because I don't need it, because I know it's a test. Okay? But here, the first part is basically the thing I'm testing. Or I call it the unit. I'm going to use upper camel casing here. Unit of work. Rubyists will not like this, but you'll have to live with it. And unit of work, when people say what is unit testing, what is the unit in unit testing, some people will say it's a method. Some people will say, hey, it's a class, as long as you get rid of all the dependencies. But from my experience, a unit can be either a method or multiple methods or multiple even classes that are connected together. And and it's defined by having some kind of a public API, a public entry point. Actually, now is a good time to discuss some of this stuff. Let's see if this will actually show this. Yeah, you tell me if this. So a unit of work is anything, I really hope this isn't a permanent marker, that has an entry point. Let's say in our string calculator, we have a method called add. Light. Now, there is a public entry point, but there are multiple types of results. There could be multiple methods going on here, but at the end of the day, there are only 3 types of noticeable results. Things that you can actually notice either from the height of this API or by a user of the API in the system. The simplest result of invoking something in code, what is the simplest result? Any ideas?
A return value?
Sorry?
A return value?
A return value. For example, a function that returns a number. That's the simplest different thing that you have. But there are other things. What's the next one? Not all functions return a number, right? Or return a value at all. What happens if you have a function where you add a user to the system in memory? It doesn't return anything, it's just void in our terms.
Side effects.
Side effects. Side effects or the behavior changes. Okay? So I call this state. State-based means that we change the state of the system so that there is a noticeable change in the behavior of the system. You add a user, now if you use a different API for logging in the user, it will finally work. And before you added the user, it failed. So you changed the state of the system, but there is a noticeable change in behavior. So add could have a return value, it can change the state, but there's one last type of end result for a unit. What do you think it is? Sorry?
An exception?
The exception is also return value. We get it back at the caller. What else?
Combined?
A what?
Combined version.
Combined? Then it's still 2 different end results. A method can have both a return value and change of state. That's true. But there are still different 2 end results, and each one of them we will want to write a different test for. What's the third one? Has anyone ever called a method that saves things to a logger and doesn't change the state of the system? Okay? If you've ever done that, then you've done the third type. Call a third party. Call a third party is anything that's outside the control of our system. For example, save things to a file system, save things to a database. Call a web service somewhere and just send them a notification. Send and forget. A lot of times, that's the end result. Not a lot, not most of the time, but definitely a lot. And in that case, we actually have to, that's the only case where we have to start doing things like mock objects, where we have to fake the third-party system and check that it was actually called. In all the other cases, we don't need mock objects. We don't need to verify that something was called. We only need to either get the return value or see that the system behaves differently. And I can tell you that if you've ever heard the idea of mock objects should not be more than maybe 5, maybe worse, 10% of your tests should have mock objects. Now, mock objects and just faking something so that you can test it are two different things. Mock objects are something that you simulate, so it looks like the other system, but you also assert that it got called. Okay? But sometimes you want to fake the logger just because it keeps throwing exceptions and you just want to be able to test something else. So you just fake it. You create a fake logger, but you don't verify or assert against it. That's not a mock object. That's a stub. So there are two types of fake objects. If you assert against it, it's a mock object. If you don't, it's a stub. That's the only difference that you need to know. So we can have stubs here, we can have stubs here, but we're never going to assert against them. We're just going to assert on the return value or on the behavior. Only here will we actually assert on the fake thing that we have. And then brings us to the to the idea that for each end result of a unit of work, we should have usually a separate test. Why is that a good idea? What do you think? Can you turn this back? Why is it a good idea to have a single test per end result, for a single concept? Well, let's see what happens here. If in our test, the unit of work begins with the method add that doesn't exist yet, and then I would put an underscore here to signify that there's the second part. The second part of the test is the scenario, or under what conditions am I testing the unit of work. Now, if we look at the requirements for a string calculator, it needs to be able to 0, 1, or 2 numbers with commas between them. So I'm going to start with the simplest case. I don't want to start with the most complicated because I want to write the simplest code possible. So I'm going to try to do this incrementally. The simplest case would be
Should add 2 numbers.
that's the simplest case.
Should add nothing.
Should add nothing. Now that's much more simple. If I give it an empty string, that's the simplest case that I can test a calculator. Now it has a requirement for an empty string. If I send an empty string to this method, it should actually return 0. So that's my simplest test case. So add with an empty string, and then the third part is the behavior or the end result or the call to a third party. In this case, it's a return value, so I will say returns 0. Now I'm not sure, I'm not crazy about this. Maybe sometimes I will do this. I'm still looking for a good naming convention that doesn't break the Ruby conventions, but you know what, conventions are made to be broken. So add empty string, return 0. That's my definition of a test, that if the test breaks, I actually don't have to look at almost at the test code. I just need to understand, to see that this scenario is failing. It almost reads like a sentence, but it doesn't have to. Now the reason I'm using this structure is because it's really easy to remember when you have this structure, that you have 3 parts. So if you look for the underscores and you review someone's code, you say, oh, I'm only seeing 1 underscore here. You're probably missing something in the name. As you get better and better at testing, you might let go of this naming convention. But the 3 parts will always be there in your test somewhere. For example, in our spec, you still have the 3 parts, but they look different. They look in different contexts. They might look something like this. Describe add with the context of np input, and then you would say it returns the default result. and this is just the method. But you will see that we have the unit of work, the scenario, and the expected behavior. The three parts still exist. If you're missing one of those parts, the reader of the code will have to go to the code and say, well, I'm happy that it gets an empty input, but what is supposed to happen? What's supposed to happen with an empty input? Because a lot of the tests that we write today, if we ever tried, might look like just this. Test add with an empty string. So I look at the code and say, yeah, great, add with an empty string. What the hell is supposed to happen now? Or we might have add with that just returns 0. Okay, that's great. I'm really happy it's supposed to return 0, but when? When should it return 0? And now you have to go and read the test code. And if there's one important thing about tests, it's readability. These tests will have to live with your code for the next 5 or 10 years. And you're probably not going to be in the same job for 5 or 10 years. So make sure that the next person who's going to read your test is not going to curse you heavily. I usually tell people, imagine that the reader of the test is a serial killer that knows where you live. So don't piss them off. Don't make them ask unnecessary questions. Okay? So add empty string return 0. And now I'm just going to use my class as if everything's great. As if it already exists. I'm going to write code even though it doesn't exist, and I'm going to define what success means to me. Success means being able to do this. String calculator. And in Ruby, classes are camel-cased, but methods are lowercase. String calculator dot new. That's how you would create a new instance of a class in Ruby. And you don't have to use the braces or anything like that. You could, but you don't have to. And then we can just say add and call it with an empty string. Now, I have to get back a value, so I will say result equals. And you'll notice I don't define the type of the thing because in Ruby, there is loose typing. We don't have to define what the type will be. So we get back a result. And the next thing we need to do is to assert on that result. So in test unit, we have different types of asserts. The simplest one that I like is assert equals. Okay? Or assert equal. And what I'm going to do is I'm going to give it the expected value, which is 0, and the actual value result. And you notice I can use braces here or not. It's just a method call. And now we can see that Ruby says name error, uninitialized content string calculator tests here at the bottom. Okay? And that basically tells me, look dude, you don't have such a class here. I actually do in a different file. I could require the file and use it, but I'm doing things in a test-driven way. So I'm going to write the code, the test, and then I'm going to make code from it. So I'm going to actually create the class right here above my tests. Later, I can move it to a different file and do whatever I want. But for now, I can just say class string calculator. Now, if I command B here again, you can see that the test didn't just fail, it had an error. No method error. Undefined method add for this class. No compilation, so everything happens at runtime. So I can go ahead to the class and say, define a method called add. And it takes something called numbers. I don't know what that something is, I don't care. I'm just going to run the code again. Command B. Now I can see one test, one assertion, one failure, not error. And you can say expected, 0 was expected, but was nil, or null. And the reason is because this method doesn't return anything. I also don't define at the method definition what is supposed to return, because I can choose what to return actually dynamically. So I can return a string, I can return a number, I can return whatever I want. Now remember, I have to see the test fail. It hasn't failed yet. Although you can see one failure, I don't consider it a real failure. Because it doesn't feel like a real bug to me. A real bug, to me, feels like when I return the wrong number. So I'm going to go one step ahead and say, I'm just going to return 1. Or actually, you know what? -1. How's that? In Ruby, you can write return, or you can just get rid of it. The last thing that you actually declare is the return value. So if I run command V again, you can see that expected 0, but was -1. Now that feels much more like something that I would want to fix, like a real bug that I want to fix. So I'm going to go ahead and change it to 0. Because in test-driven development, the second stage is to fix the tests, but to make the test pass, but to make them pass in the simplest way possible. I only have a single test that only expects a single value. So there is no reason for me to actually create logic. Okay? I can actually go to my manager now and say, look, it's not working for all the cases, but if you give it an empty string, it returns 0. Yes, then my manager will say, but then what happens if you give it a different number? I say, great idea. Let's go and write a test for that. Because I can't change the code now. All the tests are passing. Right? The first rule of TDD is you can't write a piece of code without a failing test. So if I want to prove that this code isn't good enough, if I want to change it, I have to write a test that proves that the code is not good enough. Okay? So I can go ahead and write a new test. And in this test, I might say add, but now the scenario changes. Add with, what do you think? What should I send in?
1 number.
1 number, okay. 1 number. What should be the expected behavior or result? Yes.
That it returns the input.
Yeah, returns that number. Okay. So string calculator new add, and I'm going to return, which number should I send in?
0.
If I send 0, my test will actually pass. Because it already returned 0. And I'm trying to prove that something is wrong. I need a failing test.
1 more.
1. Any other ideas? Sorry?
-1.
-1? Yeah. What else? I'm just going to wait until someone says a different number.
42.
Oh, 42. 42. This happens a lot. Then I would expect a 42, right? Now, this might look like a good idea, but it's really, really wrong. Never, never ever use 42. Never ever use numbers where the serial killer comes in 6 years later, puts serial code and says, 1 number. But why 42? What's so special about this number? I don't know. I'll just use it then in all my other tests. And then you have hundreds of tests using the number 42. Because numbers, when nobody knows them, they procreate. They begin to have children that look exactly like them. So when people don't understand your test, they say, I'm not touching that. But obviously this is important, so I'm just going to repeat that. So never create magic numbers or magic inputs. Always make sure that the reader of the test knows what's not important. So 42
Is not important. So create a variable which is called not important.
not important. That's a good idea. I can create a variable. I can even say 1. Now, why does 1 feel not important? At least to me. Because I look at the test and say 0, and then a single number is just 1. It's the first one that feels like a real number, but it's at the bottom of the stack. So it's the first simplest number. If I had used 2, it would feel weird. But because I use 1, it's the first positive one. it kind of feels okay. Now, sometimes it's not going to feel okay to even use one, and that's when I would use a variable. I would say some number. Sometimes some number, that's the only way to do it. But in a lot of ways, I just use the simplest form of that requirement, and people realize there's a pattern matching in our brain. People realize it's not important. When you look at loops and you see I or J in the loop, you know that they're not important, the name is not important. It's the same thing here. The most obvious values, the simplest values, will feel not important. So even though your hunch is definitely more readable than this,
So how do I let people hear?
once you get out, you can't get in. I'm sorry. I'm just kidding. When you just bang on the door and someone will just open the door for you. The toilets, by the way, are just on the other side of the whole corridor, on the left. Okay, so now we have a failing test. One expected but was 0. Now I can actually go ahead and make all the tests pass in the simplest way possible. So there was someone just waiting there for 15 minutes.
It's okay now.
Okay now. You guys are so polite. You can just bang on the door or just call me or something. Now my job is to make all the tests pass in the simplest way possible. So the way I think about it is that I'm the laziest developer in the world and I have to go home in 5 minutes. What do I do? What's the simple thing I can do just to get rid of all these things that I have to pass? So for example, I can just say return the numbers, but convert them to an integer. How's that? To not 1, but to I. To I is to convert something to an integer. If I run this, what happens? Get 2 tests, 2 assertions, but no failures. Okay? That makes sense, right? In Ruby, it's much easier to convert things from one thing to the other. It's a very forgiving language. In C#, this would not work.
So you mean an empty string is 0?
Yep. Looks like it. I don't have to realize this. I can just run the test and find out. And that's the nice thing. Okay? Questions so far? Simple things. Now, what happens now? There is all the tests passed, but now there is something wrong that's starting to build up in my test that could cause me a lot of grief later on. Because, I don't know if you've noticed this, but string calculator is instantiated in 2 places. Okay. Now, what happens if tomorrow I add a requirement to the constructor of string calculator? What happens to all the tests? Well, suddenly, immediately, they stop running, and they fail. And now I have to go to all my tests and start fixing them. And that's one of the pains in unit testing, is that the maintainability aspect actually hurts you if you don't plan things in a more maintainable way. So one way to stop this pain, so that tests actually help us instead of waste time, is to create a factory method. Now there are different ways to solve this, but the way I like most is to create a factory method in the test class. So I'm just going to define a method called calc. And this method just returns a string calculator.new. And now, in all these places, I just say calc. Now, there is a reason I'm doing it when I only have 2 tests. Because now I only have to change a new test. If I was doing this when I had 10 tests, this would already feel like a pain in the ass. So I'm doing it as soon as I see repetition in the creation of objects, I fix it once. Now, if tomorrow I change how string calculator is created, I just have to go to one method and change it, and immediately all my tests continue to work. This is a very, very simple thing that you can do that solves a lot of the pain and problems with the maintainability of tests today. Okay? You'll also notice that I have like an empty line between the act part, where I act on objects, and actually the assert part. To me, that feels a bit more readable than this, although for such simple things, I'm not sure it's very, very different. So now, we actually have something that works incrementally for 0 numbers and for a single number. I mean, that's the cool thing about TDD, is that even in fractions of an hour, you can actually show demos. You can actually incrementally build things. Instead of working for a whole day and not having something for a week, here you can actually have something within an hour, within half an hour, that you can actually feedback and show. Think of it like a mini iteration, micro iteration. If in Agile we want to work in iterations, then think of it like code iterations. We do things incrementally so that we can get feedback as quickly as possible. So we can ship and get feedback, and then see that we're actually doing the right thing. Now, the next requirement is not just a single number, but 2 numbers. So I know what to do now, right? I go ahead and I write a test. But this time, their scenario is 2 numbers. 2 numbers, what's supposed to happen?
Return.
Sums them up, yeah. Okay. Calc add, what should I send in as a second number? 2. That's right, it's the next simplest number. Should I send in 1 and 1? Not necessarily, because that looks very magical. Why 1 and 1? There's something important about that. 1 and 2, I can just see the pattern, I realize it's really not important. Let's see.
Just
Yeah.
one question, because you said you would like to remove repetition and duplication in your tests as
Yep.
soon as you see this, but we already have exactly
Duplication
the-
of creation of objects.
Okay. No.
Now, there is maintainability and then there is readability. I would rather be more readable than maintainable. Because if I'm very maintainable but no one can read the tests, you've already failed. Okay? Because no one can ever change the test, because it's very maintainable, but no one can change it. No one knows what to do. So, for example, I've seen this a lot in the .NET and Java space, where people have hierarchies of base classes of tests. And so the test looks just marvelous, like one-liners or something. But you don't know where that something came from, what the state is, how do you change the state of it? You have to go 3 lines down, 3 steps down in the hierarchy to change one abstract method. So it's very maintainable, but everyone is afraid to touch the code. So and the whole point of this is that it should feel simple, no more than a couple of like changing Lego bricks. So hopefully that I'm maybe a factory method somewhere, but no more than that. Okay?
So usually you don't like just moving these 2 lines of code to one method which takes input and output, like assert that sum is correct and.
So for example, you would say
it's
like this: def assert result, right? Input and expected.
yeah, maybe later on. Yeah, but
Oh, hold on. Let's see where this exercise takes us. Add input and assert are equal from expected. Yeah?
Yep.
And then in our tests here, we would say assert results from 1 and 2 and 3. Like that?
Something like this.
So the difference is 1 line of code.
In every test. In every test.
Yeah, okay. So and you're trying to solve the maintainability problem here?
No, I'm just, I was curious about this duplication, but you
Well,
already
it's-
said
well,
about...
If it's that simple, I probably wouldn't do it.
Yeah.
If it's maybe a 3-4 lines of code, maybe I would
Yeah,
start doing
okay,
it. If I keep repeating very complicated things.
Yeah, I see, I will not kind of try to...
Now this is important. A lot of times, sometimes I do this, but what happens is that you get into the. It's very easy then to start doing things like this. So, like, for, etc. And then start doing very crazy things. And you say, okay, what's the problem? It's very readable, it's very maintainable, but there is a problem here. Now the problem with this is that, let's say that we have this line runs, but this line actually fails. We get an exception. So execution stops here. These lines never get executed. Okay, if they never get executed, we'll never know what the result is. And it's like a doctor looking at a patient and only hearing half the symptoms. You might go and fix in the wrong place and then realize that this still fails. Now in a book called X-Unit Test Pattern, this is called test roulette or assert roulette, where you just run this and you wait to see what happens on the next one, and on the next one, and the next one. Or you start doing this, comment this, and then run this, comment this, and then run that. When if actually what's supposed to happen is that each one of these is its own test, and then they run separately from each other, and you don't have to worry about it. Now if I just do these simple things and I get this, there's a very big chance a lot of times that I will want to do this, because it looks like a very simple thing to accomplish.
Well,
yeah.
also is you hiding what you're actually doing. I mean,
There is also some hiding here where another layer of abstraction gets created, etc. So I'm not crazy about creating a layer of abstraction if I don't need to, absolutely. Hopefully there is some knowledge to that was added. Let's see. Okay, you can see 1, 2 passed, and then 1 fail. So assert results, expected 3, but was 1. And we can keep this for now. But I have to tell you, for me, it doesn't really make a difference on this such a simple set. So now we have 2 numbers, and now we need to fix 2 numbers in the simplest way possible. Okay? Any ideas what we should do? People who know Ruby, what would you do?
Probably.
Sorry?
I've already spoken 3 times, I'm done.
You've already spoken 3 times?
Yeah.
Okay. Okay.
What was the question? We didn't pay attention.
Aha. You need to now solve the problem of getting 2 numbers as input. What's the simplest way to fix it? Yeah.
Yes, split.
Split. We can split.
And a regular expression.
No regular expressions, please.
Damn.
Because what I want you to learn to do is to break a problem into very, very small pieces. Regular expressions are like taking a machine gun and killing like a fly. This is a very simple problem. I don't even need to split if I really didn't want to. And sometimes when you solve things in the simplest way, you realize that you've forgotten to write. You never thought of some test that you might want to write. For example, what if I said numbers, the first number, make it into an integer, plus the second number. Yeah. What if I know that I have 2 numbers, there's only a single character, and I know there's a column between them, maybe I can make it past this time. Although, when I do this, I'm failing all the previous tests. So I have to account for the fact that I might say, return numbers, and this is cool, you can do this in Ruby, return numbers unless numbers include And then you can write a question mark, because in Ruby, you can have question marks as names of methods. So they look more Boolean. If members include, okay, so only do this line when members don't include that. If I run this now, ooh, now I have 3 failures. You see I have 2 lines of production code, and I have 3 bugs. Any ideas what happened? You can look at here. Let's see. Spent is 0 but was an empty string, and you can see at the test name add an empty string returns 0. Aha. Oh, because we didn't say numbers to I, to integer. Okay, now we still have 1 failure, but I guess we're close to what we need to do. And then we say add numbers, 2 numbers, sums them up. Expected 3, but was 99. What the hell happened here? This is actually very common in different versions of Ruby. The string is just a byte array. So when you go to a specific index, what you get is the bytes. So you kind of calculate the values of the bytes. So we just need to transform it into a char first. So we just say char on here, and char on there, and then convert it to an integer. And hopefully that should be okay. So now all the tests are passing. You can see 3 green dots, that's a good thing. A lot of times in TDD people say red, green, refactor. Start with red, then you see green, then you can refactor. You can change the code to make it more readable, more maintainable. Now would be a good time to do that. Yes?
I've lost you somewhere. I've got 3 errors.
Yes, that's a good place to be.
Okay.
You know it's better to have 3 errors than not to have them, right?
Yeah.
So this is where, if I had 3 errors, this is where usually I would take a break and go to the toilet. And then when I come back, I remember exactly what I need to do. So it depends what you were doing. You can always undo and go back to the next simplest thing that you did. And go back to only having 1 error. So just undo and then try to do it again. Yes?
Another thing is to read the error message.
Read the error message, damn it. Yes. It's important. Although sometimes it's very unreadable. It's one of the things I hate about the Ruby error messages. Sometimes they just give you the world of trees and no forest to go for.
Possible to add a message on the asserts, like in
You could add a message to the asserts, but I would rather have a really good test name, so then my message doesn't mean anything. So
yeah.
if the test name is good, you don't need to have a message on the asserts. Okay, because I see exactly what was supposed to happen. So again, the thing I'm doing here is I'm handling 2 cases. I either handle a single number, so I return that number to integer. I take the string and I turn it to an integer, unless the string includes a comma. Okay? Now return, when I write the word returns, it forces a return. Everything after that doesn't get executed, unless this is true. And then this, I could write return here. This is handling 2 numbers. I still haven't refactored it yet, but I'm basically taking the first number, turning it to a char, because it's a byte array, then turning it to an integer. And then the second number, which is the 3rd ASCII character, right? If it's 0, that's the first number, then 1 is the comma, then 2 is the second number. Okay? So what I want you to do is to try to get up to this stage where you have 3 tests passing, okay? Questions? Who has all 3 tests passing? Just raise your hand if you do. Okay, most of the people here. And so let's take a couple of minutes and help your the person sitting next to you if they still haven't have all the tests passing. Do you have everything passing more?
yeah.
Of course. Now, while you do it, I'm just going to refactor. So it's time to refactor things. But am I running too fast? You should tell me.
I was just saying that when I get back here, and you're going on, and I'm going to agree.
So next time, just raise your hand and tell me, hold on. Okay?